Now let us continue from where we left in the last video. Now, since we have already done the definition or the statement of Boyle's law, we'll continue from the mathematical interpretation of Boyle's law. Clear? So let's start. Now, since we have already taken temperature as constant, it will not be a part of our mathematical calculation. So when we start, we write P, that is pressure, varies as, now this varies or proportional sign is something that you must have learnt in mathematics. It varies as 1 by V. Why did I write 1 by V? Because it is inversely proportional. Had I written P varies as V, that would have been directly proportional. So P varies as 1 by V, that is pressure is inversely proportional to volume. Now, if I want to remove this variable sign and if I want to bring it to an equality sign, what I have to do is I have to multiply this 1 by V with a constant which is K. K can be any constant. So P is equal to K by V or PV is equal to K. If I am clear till here, students, please write down that Boyle's law can also be written as at constant temperature, the product of pressure and volume of a gas is constant. I repeat, at constant temperature, comma, the product of the pressure and volume of a gas is constant. That is, P into V is equal to K, where K is my required constant. Clear? Now let us move to further parts. If the gas has initial conditions P1 and V1, now what exactly do we mean by this? What I mean to say, students, is that suppose you are taking up a particular gas and the first condition, the first pressure and volume is something. Suppose the first pressure is 1 atmosphere and the first volume is maybe 5 liters. And at constant temperature, a change occurs in the gas and its pressure and volume changes. So how do we formulate the Boyle's law according to it, or how do we formulate the Boyle's law equation? My Boyle's law says that come what may, at constant temperature, my pressure and volume product will be constant. So if my initial condition is P1 and V1 and my final condition is P2 and V2 after a change, so P1 into V1 will be equal to K, which is my constant, and P2 into V2 will also be equal to K, which is again my constant. Therefore, P1 V1 is equal to P2 V2. This is my original Boyle's law equation. This is my original Boyle's law mathematical equation for solving all numericals. I'll just repeat it for clarification. If my initial conditions before any reaction happens is P1 and V1, and if my final condition after the reaction or the change is P2 and V2, therefore P1 into V1 is equal to K, which is any constant for a gas. P2 and V2 is also equal to K, which is again the constant for a gas. Therefore, P1 V1 is equal to P2 V2. My temperature remains constant. That is why I have not brought it into consideration for any calculation. Clear? Now, also remember that these points remain constant here also. That is the given mass of a dry gas. We are always talking of a particular mass and we are always talking of a dry gas, never a gas dissolved in water. I hope I am clear till here. So my mathematical equation for Boyle's law will be P1 V1 is equal to P2 V2. Okay? Moving on. Now, since we have already learned how they are related to each other, let us learn to plot some graph how to plot, let us see. The first graph, if you can look in the page, is a pressure versus volume graph. I have taken P in the y-axis and V in the x-axis. Now this is common sense from your information of mathematics students. Since P and V are inversely proportional, that is, one increases and the other decreases. So if I plot a graph of them, it will be a line with a negative slope. As you can all of you see, it is a line with a negative slope since P and V are inversely proportional to each other. Now let's look at the second one. The second one is P versus 1 by V. Now when we talk of P versus 1 by V, mind you, I have already inversed V. So now this P and 1 by V are directly proportional to each other. I repeat, when I write 1 by V, I have already inversed V. So now this P and V are directly proportional to each other, and hence it will be a positive sloping line. But I will not start it from the origin point, because pressure and volume of a gas can never be absolute zero, and the origin means if the coordinates of the origin is 0, 0, it is not possible in science for pressure and volume of a gas to be absolute zero. It's a hypothetical concept. Let us move to the third one. The third one is a PV versus V graph. So in the y-axis I have PV and in the x-axis I have V. Now if you remember what I said in my last topic, in my last discussion, that come what may, the product of pressure and volume of a gas is always constant. So even if you go on increasing the volume, the pressure and volume will be constant. Pressure volume product is constant, and as a result your graph looks like a horizontal line. There's no question of slopes here because it looks like a horizontal line since PV is always constant. Let's look at the second situation. I've taken a P versus PV curve, and my P is again in the y-axis, my PV is in the x-axis. Again, the same thing, since PV is constant, is always constant, and P can differ. So even if the value of P increases or decreases, PV will remain constant at one point, and as a result you get a vertical line in your graph. I hope I'm clear with all the graphs, and the next topic that we deal with will be numericals on Boyle's law.